Hey guys, welcome back to A-Level Lessons. In this video, we're going to be looking at one topic of your math statistics syllabus that has been very highly requested. By popular demand, it is finally here. It is going to be on hypothesis testing. Alright, so hypothesis testing is one part of your statistics syllabus that I think is very easy to score. Okay, once you nail down roughly how the whole thing works, okay, and you kind of understand what your critical values are, what does your standardized test statistic mean, what is the p-value, and all the various different parts, okay, to this small little chapter. Okay, actually it's quite large, right? So this video is going to be slightly longer, so I'm going to break it down in the description below, and I think the video itself will have its own segment. So if you want to skip to the segment that you are a bit unsure of, go ahead and skip to those. If not, I'm going to be covering everything that you need to know, so it will take a while, and it's quite a chunk full to actually go through. Alright, so firstly, let's start off. Okay, what does hypothesis testing basically refer to? Okay, so hypothesis testing, for those of you who are unsure, it is like what the name suggests. Okay, we are basically testing a hypothesis that is testable basically on a certain set of data. Okay, so given a specific set of data, you will basically use it, okay, whatever you have collected, to come up with a statistical hypothesis. So usually the question will give you a bunch of data, okay, for A-levels. Okay, they usually give you a bunch of data, and from there they will ask you to find what your null hypothesis is. They will usually give it to you, okay, and ask you to find what your alternate hypotheses are, and then from there find out what the p-value is, and whether the test statistic actually lies inside the critical region, and whether we should reject or accept your H naught, okay, which we later will go through. It is basically your null hypothesis. So let's just start off with the basics. Okay, what does it mean for a sample to be random? So, okay, let's just go through. So, for a sample to be random, okay, all of this actually, I mean, it should already be kind of like covered in your binomial and normal distribution. But I'll go through again. Okay, so for a sample to be random, okay, there's basically two different parts to it. Okay, the first is that there is an equal chance of whatever the item is, okay, being in a sample. Okay, and secondly, would be that the selections that are made are done independently. Alright, so for an item, okay, for a sample, depending on what the question is, of course, I spelled it wrong, my bad. Independently. Okay, so for an item, okay, or for whatever the given description is of the question, okay, if the question asks you, okay, what does it mean for a sample to be random? Very simply, there's just two parts to it. Okay, one of it is that there's an equal chance of that item being in a sample. Okay, and that the selection, okay, of this item being chosen is made independently of another. Okay, so it doesn't mean that, let's say if I pick a red ball, definitely the next one will also have to be red. Okay, if I pick a red ball, the next one could be blue, it could be yellow, it could be black. Okay, it could be any other item in this sample. Alright, so in our hypothesis testing, okay, you're going to come across these two terms a lot, okay, which is going to be known as your null hypothesis, right, as well as this other thing called the alternate hypothesis. So these are essentially the main concepts that you're going to be needing to know for this entire hypothesis testing. Essentially, the null hypothesis is basically, in math terms, okay, we call it H naught. Okay, and this is what the claim value is. Okay, claim value means to say that the question, okay, usually they will give in the question, okay, has claimed that this certain value of whatever the sample is, okay, is supposed to be valid. Okay, so this is a claim value. Okay, a null hypothesis is a counterclaim. So it goes against whatever this claim value is, okay, your H naught, which is what your null hypothesis was. Okay, and to say that, given a certain scenario, okay, possibly your null hypothesis has to be rejected. Okay, so it could be accepted, it could be rejected as well. So hence brings us down to what our distribution would be for this entire syllabus, which is going to be that your sample mean, Okay, your x bar is going to be normally distributed by mu. Okay, this is going to be whatever your mean value is. Okay, and then your sigma square over n. So this is like your central limit theorem. Okay, similar things. So we're going to be looking at a sample size. Okay, and what the sample mean is going to be distributed by would be of a normal distribution with a mean value of mu, and your standard deviation, okay, or your variance, which is going to be sigma square over n. Alright, so it'll be over the sample size. Okay, so n is the sample size. Let's say if there's 50 balls in the basket, your n will basically be the value of 50. So this is just the really the basic parts. Okay, is it important? I would say not really. Okay, because it is kind of like just info that you would already be given in the question. Okay, so this is kind of like just for you to have a rough idea of the basics. Okay, the foundation of what hypothesis testing is, what it lies around. Okay, essentially your null hypothesis, your alternate hypothesis, and what this entire distribution is basically distributed by. Okay, it is this normal distribution. Okay, so we go on to the next important part of this hypothesis testing, which is going to be your test statistic. So this is something that you're going to be hearing a lot. Okay, in fact, you would be using it when it comes to proving, right, whether a certain claim value, okay, whatever the question gives. Okay, say the question claims that there is a certain number of test results, okay, that have been positive. Okay, so if the question does something like this, okay, you can use your test statistic as one of the ways to prove. Okay, another way you can actually use it, which you'll realize later on, is via this thing called the p-value. Okay, so we'll go through this test statistics first, and then we'll look at the p-value later on. Okay, but essentially just take note that these are two ways in which you can actually use it for your hypothesis testing questions. Okay, so let's just go through the test statistic. Give me 1 second. Okay, so the test statistic. Okay, some of us in your schools will call it the standardized test statistic. Right. So what this test statistic is, okay, is denoted by this math term or math value known as Z. Okay, and the formula goes whereby it is your sample mean x bar minus the claimed mean. Okay, so whatever the question has claimed the mean to be, which is your average. Okay, so this minus this over sigma over the square root of your sample size, root n. Okay, where Z is normally distributed as n 0, 1. Okay, so this is a very classic distribution. Okay, everyone has to know this. So your test statistic, okay, is normally distributed by 0, 1. So just take note of that. So when it comes to this question, okay, what you have to do next is, in the event that the question gives you all of these values, okay, you can essentially use the Z value to determine if it is within the critical region or if it is not. Okay, so we'll look at what this whole critical region thing is all about. Okay, so essentially, once you have gotten it to this stage, okay, you are pretty much set. Okay, you already roughly know, based on whatever the values of the question is given, okay, to roughly find out what your test statistic is. Okay, so next we will move on to what we call the critical zones. So you have got the critical region, the critical value, and the level of significance. So my bad. Okay, so the critical region, the critical zone or critical value, and the level of significance. So these are the three main key concepts that you need to learn. Okay, these are usually given in the question. Okay, but there usually are three different cases. Alright, so usually the question will give you, okay, given that the mu, okay, that means your whatever the sample mu was, okay, or sample mean was, okay, is more than a given claim value. Okay, then from there you will have to look at a specific area of the critical region to reject your null hypothesis. Okay, what I mean by this, okay, let's just take a look first. So the first case would be when there is an increase. Alright, so let's say the question gives you that your H1 occurs whereby your mu is more than your claimed value. Alright, so the question will give you all this, so you don't have to worry. Okay, the question will ask, given that this is more than your claimed value, prove that this is either supposed to be rejected, the null hypothesis should be rejected or not. Okay, so this will look at the upper region of the critical area. Upper critical region. Okay, so essentially if you're looking at the curve, okay, it's a very, very basic SD curve. Okay, you would have something like this. And the middle part is where we have your average, your mu. Okay, which side of the curve would this be on? Okay, when it's saying that there is an increase, okay, naturally you would think that it is on the right side of your mean. Okay, because the middle part is where mu exists. So if you're looking at the upper portion, it will be over here. So this is if there is an increase. Okay, and this is the region over here whereby we actually reject our null hypothesis. Okay, our null hypothesis is essentially our claim value. Okay, so this is one of the regions that you'll be looking at for an increase. Okay, the next one will be for a decrease, meaning to say that the question will give you something like H1, whereby your mu is less than your claimed value. So if this occurs, then it will of course be the opposite. It will be the lower part of the critical region. Okay, which on the curve will look something like this. Okay, pardon my drawing, it's a bit shaky. Okay, the lower part, okay, will be, you'll be rejecting any value that falls within this range over here. Alright, and the last one, okay, will be if the question says that there is no change. Okay, the question says that either there's no change or there is a change. You look at this thing called a two-tailed test. So if let's say it says that whatever the null hypothesis was or whatever the claim value was, okay, it says that it has changed. Okay, if it has changed, this would mean that your H1 would be at a value that is not equivalent to your claimed value. Okay, meaning to say that it could either be more than or it could be less than the claim value, so you have to identify. Okay, but if you're looking at the curve, you'll be looking at these two regions over here. Okay, meaning to say that so far for all of these regions that we have shaded, okay, we are looking at these regions to be rejected. So any value that falls within this region here would have to be rejected. So then comes the question, right? How do we find this? How do we find this region? Right? So how do we find this region is very, very simple. Okay, you just need to use the inverse norm technique. Okay, this is all calculated already. So in order to find the region or the shaded region, okay, just simply use your inverse norm. So on the calculator, okay, you use your inverse norm and you'll be able to find, okay, so the area of the curve is essentially the level of significance. Okay, so whatever the question has given you, okay, let's say a 5% level of significance, if let's say the value is something like 0.4, then of course you know that let's say if you're looking at less than, okay, it definitely will fall within that region. Roughly understand? Okay, so the area of the curve is the level of significance. So the area of curve is the level of significance. Okay, I will do some example questions. Okay, in fact, I think I already have some up on the channel, so you can go ahead and check those out if you're still unsure how we can actually do this. Okay, but of course I won't recommend anyone to actually use this method. Okay, reason being is that it sometimes can come with mistakes, okay, if you key in certain values wrongly. And usually the p-value is easier to find whether the test statistic actually lies inside or outside the critical region. Right, but for the sake of having to go through this part, okay, this is basically how your curves will look like when it comes to looking at your critical region, okay, the critical values, okay, as well as the level of significance. So just take note that this is how your curve will look like. Alright, so next we move on to the next, in fact, the most important part of this entire chapter, which I think is going to be your p-value. So the p-value. Alright, so what the p-value is, okay, is essentially it is basically when it comes to your null hypothesis testing, okay, the p-value is basically the probability, okay, of obtaining these results, okay, at least either where it is at a very small value or a very high value, okay, whereby these results are actually being observed, okay, and this is assuming that the null hypothesis is correct. Okay, so it is essentially like a probability value. Okay, so the p-value would make up the entire part of, like just now the curves. Okay, it will make up the part of where the curve is actually shaded at. Okay, so from the p-value, we can actually identify if the test statistic will actually lie within the critical region, okay, inside the critical region, or whether it will lie outside. So let's just go through, okay, when the p-value is less, okay, is less than the level of significance. Okay, it implies that the test statistic lies inside the critical region. Okay, and when it lies inside, what actually happens is that hence we reject the null hypothesis H0. Alright, so the p-value, okay, if it is less than the level of significance, okay, usually it will always mean that the test statistic will have to lie inside, okay, the critical region. Okay, if we look at the curves above, let's say we look at the first case, if our p-value, okay, is actually less than the level of significance, okay, which is going to be where this curve, this shaded part is at, okay, it basically means that this test statistic is going to be lying inside here, okay, inside this critical region. Okay, our p-value, let's say, can be somewhere around here, where the green marker is. Okay, so because it lies inside the critical region, okay, we would have to reject our null hypothesis. Right, this is if it is less than the level of significance. Okay, because remember, we are looking at the area over here. Okay, so if the p-value is essentially like giving you an answer to the area of whatever that curve part is. Okay, so if you're looking at the area specifically, definitely if the p-value, the area is lesser than whatever this level of significance is, we would have to reject. Okay, basically the level of significance is the entire yellow shaded part. Okay, so the entire shaded part is our level of significance, let's say 5%, okay, 0.05, right? Our p-value, let's say 0.03. Okay, then definitely the area of that is going to be lesser. It would fall within this 0.05 region. Hence, we will have to reject H0. So this is how p-value actually ties into your curve. It is the exact same for the other two cases, except for your two-tailed test, you have to be sure whether it is on the positive side, whether it's less than or whether it's more than the critical value. Okay, the critical value, for those of you guys who are still unsure, okay, is basically this part over here. So it's where the critical region stops. So over here is where our critical value is going to be at, this line. So this is the p-value, very important concept. Okay, always use a p-value as far as possible. So okay, so I will stop here real quick. Okay, go ahead and take some moments to actually absorb everything. And then we'll move on to how we can use various steps, okay, to actually solve a hypothesis testing question when it comes to the exams. So let's move on to the next part on how we can use certain steps to actually solve a hypothesis testing question. So steps to solve a hypothesis testing question in the exam. So firstly, you have to acknowledge that in the exams, okay, a lot of times the question will give you a lot of values that you need to know already. So what you need to do firstly is to actually just simply state the null hypothesis. H naught, as well as the alternate hypothesis H1. So just simply state, okay, what the null hypothesis is. Okay, so H naught is, let's say the question is something like H naught is a value of mu equals to, let's say 2, okay, for example. So your alternate hypothesis will be whatever the question says. Okay, let's say that testing for something that is greater than the null hypothesis, okay, will be mu more than 2. So simply just go ahead and state, okay, what your null hypothesis are for both your, go ahead and just state what your alternate hypothesis as well as your null hypothesis, the values, what they are. Okay, go ahead and write it down. So this is important, okay, because later when it comes to solving, let's say if you need to find whatever the values were, you can easily find it over here. Okay, your null hypothesis, all the values will already be over here. Okay, so once you've done this, move on to the next step, which is to state the distribution. State the distribution of your x and your x bar. Okay, so your sample and your sample and your original distribution. So this can be something like x goes by a distribution of whatever it is supposed to be, and your x bar could be something like, okay, this is just an example, right? So an x bar could be something like n, which is let's say 30 and maybe 0.385 over a sample size of 40. Okay, and then by central limit theorem, if the question is didn't state, okay, and if the sample size is large enough. So this could be an example, okay, of how you would just simply state, okay, your distribution. Next one would be to write down the level of significance. So write down the level of significance. So this helps you to keep track, okay, what is the region that we're looking for, significance. So for example, the p-value, okay, goes by a certain value of, your level of significance, okay, is at a 1% level. Okay, so there's something like level of significance, let's say 1%. Okay, so we know we're looking for anything that is going to be either less than or more than 0.01, depending on what the question has asked. Okay, and if our p-value is, let's say, more than this value, you will know that you have to either reject, okay, your null hypothesis or to accept it. So we'll look at how we can do this. So next one is you have to compute the test statistic. So this is good because it helps you to act as a backup plan. Okay, in the event that your p-value is wrong, okay, you will know that your test statistic should always be correct. Okay, because the values are just all in the question. You just need to plug it into the equation. So this would be whatever your x bar is minus your mu. Okay, we've already gone through the formula. So over your sigma square over n. Okay, and this will give you a value. So this will give you a certain value, and you can basically use this value later on to determine if your z value is more than or less than your critical value. Okay, so this will be back to your diagram part, and then you know whether to reject or not to reject your null hypothesis. The next step is to actually find the p-value. So to find the p-value, you have to use your graphics calculator, right? This one I cannot help you. Simply use your z-test. Okay, go ahead and key in all the relevant values, okay, your mu as well. If it is less than, if it's more than, if it's not equivalent to, and simply just compute. Okay, this one you should have already learned in school. Okay, so whatever the p-value is, okay, let's say the p-value is, let's say, 0.01394, for example. Okay, so this will be basically what you get from the calculator. So after this step, you would want to make a conclusion. So make a conclusion. Okay, because at the end of the day, what we are trying to get at is we're trying to say whether we should be rejecting the null hypothesis or whether we should not be rejecting the null hypothesis. So your conclusion very simply would be that if the p-value is less than the level of significance, we would have to reject H naught, right? Meaning, because as we saw in the diagram just now, okay, if it's less than, it means that this value, this p value, okay, let's say given, let's say this region over here, okay, if it is less than, okay, it means that let's say this whole region is 0.5. Okay, and let's say the p-value is only 0.1. Okay, it means that it only makes up, let's say, this proportion here. Okay, it actually falls within this value of 0.5. We would have to reject it. Okay, because anything that's within this shaded area over here, we will have to reject the null hypothesis. Okay, so we reject H naught and we conclude that there is sufficient evidence at the whatever the percentage of level of significance is. Okay, in let's say this case is 1 as a level of significance, or I mean if you're looking at the diagram it will be 5, so it depends on whatever the question is asking. Okay, to conclude that your mu, okay, as we saw just now from the very beginning, right? So remember, that's the reason why we laid it out at the start. Okay, we laid out that whatever the mu value was, okay, whether it's going to be more than 2 or less than 2, or equivalent to 2, okay, or not equals to, okay, that mu is less than, okay, this one could be less than, it could be more than, it could be that there's no change, whatever the value is. Right, so this will help us to determine whether our mu, okay, whether our null hypothesis has been rejected, and hence whether whatever the question has given, okay, is actually proven correct or wrong. So on the other hand, okay, if it is the opposite. If the p-value is more than the level of significance, okay, we do not reject H naught. Alright, there is insufficient evidence at whatever the percentage level is to conclude that the mu value is less than, more than, not equivalent to whatever the value is. So this would be how you would answer the question when it comes to making a conclusion. So this is what we call answering a hypothesis testing question. So just to go through this last part, okay, why do we not reject it? Okay, because let's say you're looking at the curve again. Okay, so this is the shaded region over here. Right, if the p-value is more than level of significance, let's say this level of significance over here, okay, let's say it's 0.05. Okay, let's say we're looking at the 5% level. Okay, if our p-value, let's say, is 0.07, okay, it means that our p-value is somewhere around here. Takes up this entire area here. Because remember, our p-value is essentially the area. So this entire area here will be 0.07. So because it's already exceeding, okay, we actually do not reject. It shows that there is actually sufficient evidence, that there is insufficient evidence, okay, at this level to actually prove that we can reject this null hypothesis. So if it's more than that, okay, we cannot reject, okay, because there's this shaded area here, this red color shaded area, right, which shows that there is a lack of evidence, okay, because it is not part of the shaded area. There's a lack of evidence to actually prove that this null hypothesis has to be rejected. Okay, so there's going to be a need for further tests at maybe a larger significant level of significance instead. So this is how we will answer the question. So step by step, very simply, let's just go through it one more time. Okay, the first step is to always state the null hypothesis and the alternate hypothesis. So what is the mu value at first, okay, of your null hypothesis? Is it if it's equivalent to 2? Okay, and the alternate hypothesis to prove is whether it is more than 2 or less than 2 or not equivalent to. Okay, state the distribution. Okay, where is it? It should always be a normal distribution. Okay, and bring in your central limit theorem if you have to. Okay, after which write down the level of significance. Okay, it should always be an area that we're going to be looking at later on. Okay, compute your test statistic. Okay, this will give you a Z value, which determines whether this value is going to be outside the critical region or not. Okay, the critical value. After which you can find your p-value using your graphics calculator. Okay, use a calculator to compute your p-value. If the value is less than, okay, we can actually make a conclusion. Okay, if it's less than the level of significance, we would reject it, okay, because it falls within. There's actually sufficient evidence, okay, to conclude that the mu value is to be rejected. Okay, on the other hand, if it's more than, then we would not reject it, okay, because there's still insufficient evidence at that specific level of significance to conclude anything. Hence, we need further testing instead. So this will be how you answer a hypothesis testing question. So some papers, okay, will ask you for an additional part. Okay, so they will ask what is the meaning of the level of significance. So I'm going to go through what the meaning is over here. So we're going to use the example of, let's say, a 5% level of significance. Okay, the question gives you this. So what it means essentially is that there is a probability of 5%, okay, or of 0.05. Okay, let's use 0.0 because you're looking at probability. So of 0.05 of wrongly concluding that the mean is less than, more than, or did not change when it is in fact the mean. Right, so when you look at the level of significance, okay, the reason why the question gives you that in the first place is because we're trying to see, okay, that this level of significance is essentially saying that there's a probability of whatever this level is, okay, of actually wrongly concluding that the mean value that we're trying to reject or accept, okay, is actually less than, more than, or they actually did not change at all, okay, when it is in fact that mean value that whatever the, let's say the organization or the chemist had originally proven. So level of significance is essentially like a test, okay, it's helping us to determine if we have actually concluded this mean hypothesis, okay, whether it has actually been at a wrong or whether it has actually been correct. So in the event that the question asks you to explain the level of significance, this would be how you would give an explanation. And that actually wraps up the entire part on hypothesis testing. I know that it's been a very, very long video and a lot of things to take in. So if you're still unsure on any concepts, you can always leave a question in the comment section. I will answer them. But just take note that for this part, I think a lot of things are actually very straightforward. You just need to really know the various steps to answering the question. Okay, get to know what your null hypothesis is, what is your alternate hypothesis, your H0 and H1. Okay, make sure you're able to compute the test statistic. Okay, that your Z is equivalent to X bar minus your null hypothesis, okay, or claim mean, over your sigma over root n, okay, or root sigma square over n, okay, whereby your Z is normally distributed by 0, 1. Okay, and after that, find what the critical regions are. Okay, if your p-value lies within the critical region, okay, we would have to reject it. Okay, if your p-value is more than the level of significance, which is essentially that critical region, okay, we will not reject H0. Okay, and after that, follow the few steps and you'll be able to answer the question quite well. And that's all for this entire part. So if you did learn something and you did enjoy this video, be sure to give it a like. I know it's a very long video and not to worry, okay, I'll leave the timestamps in the description. You can always just skip to the part of the video that you need more help on. Okay, any questions you can leave in the comment section. I have gone through some hypothesis testing questions before, so I'll leave their links in the comment section as well. Not the comments, sorry, the description below. And you can always go ahead and check those out. If not, that's all I have. I'll see you guys in the next part. Be sure to subscribe and to like as well. And I'll see you guys in the next video very, very, very soon. Have a good one. Bye-bye.